Section 5.6, we're going to still be distributing, but we're going to focus on special products. The first thing they're going to do is they're going to take distributing, they're going to formalize it with this process which they call FOIL. I'm actually not a huge fan of FOIL because FOIL only works when we have a binomial times a binomial. And if you look at even our last example in the last section, FOILing won't work. I would encourage you to know just how to distribute, where this term multiplies across everything in the second group. The second term multiplies across everything in the second group. That idea of distributing is going to last you longer. But what they do is they go, look, the first with the first, the x with the f, so that's our f, and then the first with the outside is the o, and then the I are the two inner, and then that last term over there is last, the last with the last. So FOIL, F-O-I-L. What does it end up doing? Well, x times x is x squared, x times 4, 5 times x, and 5 times 4. And then we combine the like terms. So, like I said, it's just a nice kind of trick, but in the long run, I call these like crutches. They're great if you're struggling with distributing. It's a great little process to help you get used to it, but you don't want to be on crutches for the rest of your life. You want to be able to walk, you want to be able to do this normally, so I would encourage you to, if you need to, use the idea of FOIL, first, outer, inner, last, but ultimately you need to know how to just distribute. Okay, here's one of our first special types. It's called the difference of squares, or I've heard it called the product of a sum and difference. I have the sum and difference of the same thing, a plus b and a minus b. What does this become? Well, let's check. A times a times b times a, and b times b. Well, when I have a sum and difference of the same thing, plus b and minus b, right, the middle terms, as negative ab and positive ab, they basically will zero out. Always. Now that's great, and there's a good pattern to see, but I'm still going to encourage you, make sure you still distribute this normally to get your a squared minus b squared. I'm warning you right now. Don't treat this like it's a magic trick. It's going to get you in trouble. Promise you. But this will always be true. When I have a sum and a difference, the middle will zero out. That's a great pattern to see. Mostly, we're going to use that in the next chapter when we're factoring. So for now, it's good to see the pattern. How should you multiply these? By distributing. Don't turn off your brain at any point, or you're going to be throwing away what should be really easy points on this test. So what is x plus 4 times x minus 4? Well, by the pattern, I think I could figure out an answer, but I'm telling you, don't do it. Just distribute x with the x with negative 4, x with positive 4, and 4 with negative 4. The 0 in the middle, those terms still zero out, so I'm just left with, and that's a great pattern to see. You should not be going straight from the question to the answer. Promise you. We can look at this also with an area model. It's kind of fun. If I have x plus 4 and x minus 4, x and x and 4, x and negative 4, and 4 and negative 4. And then these middle terms basically zero out, leaving us with just the x squared minus 16. This is also in that pattern. It's 5 plus something and 5 minus the same thing. So it's a sum and difference, or a difference of squares. So what's the answer? Distribute it out. 5 times 5. 5 times 2 minus 10w. 2 times 5 plus 10w. And 2 times negative 2 minus 4w squared. What happens in the middle again? Plus 10 and minus 10, zero out, leaving us with 25 minus 4w squared. Some of you, and I actually would prefer this is fine for now, this is all they want, but some of you have a good habit of putting that variable first. That would not bother me. Okay. 3a to the 4th minus 5 times 3a to the 4th plus 5. Still the same pattern. Still the same process. Don't go straight to an answer. It's not worth it. 3 times 3. A to the 4th times A to the 4th. Shouldn't be using the rules on that. That should make sense. 3 times 5. Oops. About 15. A to the 4th. 5 times 3. And 5 times 5. The middle, positive 15, negative 15, goes away. So we're left with 9 a to the 8th minus 25. Here's our next special product. It's called a product of squares, and this could be either with a positive or a negative, but I'm going to emphasize right now that a plus b squared is not a squared plus b squared. Don't do it. It's a trap. It's not right. Don't make this a trick. What does a plus b squared mean? Well, it means a plus b times a plus b. So write it out and distribute it. A times a gives us a squared. A times b gives us ab. B times a gives us ab. And b times b gives us b squared. Now these in the middle, don't zero them out because they don't make 0. They're both positive. Positive 1ab and positive 1ab combine to make positive 2ab. And this will always be true. And that's a great little pattern to see. How are we going to get it? By distributing. It's good to see patterns, but don't make it a magic trick. I'm telling you, it's going to get you in trouble. How are we going to do a minus b squared? Well, we're going to write it out. A minus b times a minus b. A times a times negative b times a, and negative b times negative b. Once again, the middle terms, this is so tempting, I'll have people do this. It's not right. It's not a squared plus b squared. Negative 1 and negative 1 do not make 0. They make negative 2ab. And if you prefer, you can actually do this once again with the area models. If you write this out, what would this be? A squared, AB, B squared, which would then give us that top line. This would be A squared minus AB, and positive B squared. And that would give us the second one. Okay, so if you like the area model, please feel free to do that. I'm not going to emphasize too much on that. But here's one reason I like this. This is called a product of squares. And why do they call this a product of squares? Well, you're like, well, we're squaring it. Okay, but this is where I think the area model actually has kind of an interesting application, because what is a square? What makes something a square, right? All 4 sides are the same. And when I set up the area model and I do a plus b times a plus b, we are finding the area of this square. How do I know it's a square? Because all of the sides, a plus b, are the same. This is also a product of squares. This is a square because it's a minus b times a minus b. So that's another reason why we call it, when we multiply something by itself, we are squaring it, because literally, visually, it creates a square. What is x plus 7 squared? Okay, once again, a plus b squared is not a squared plus b squared. Don't do it. It's a trap. You put x squared plus 49 with no work, you're getting no credit. It's completely wrong. What is it? Well, what does x plus 7 squared mean? How about x plus 7 times itself? The x and the x make, then we have plus 7x plus 7x plus 49. So we have x squared plus 14x plus 49. 3t minus 5 squared. I know that's going to become 9t squared minus 30t plus 25. But I'm not using a magic trick for that. Literally, all I'm doing is this in my head. 3t times 3t, 3t times 5, I'll get a minus 15t, then I'll get another minus 15t, and then I'll get a plus 25. And then the middle terms combine to make minus 30. The rest of it comes down. Quick recap again, and this will be the last thing, is that if I have a plus b squared or a minus b squared, do not just make them a squared plus b squared or a squared minus b squared. Don't do it. If you do that, you're going to be throwing away very quick and easy points. Write them out and distribute. The purpose of this section is not to teach you magic tricks. It's to show you some patterns that we're going to use more in the next chapter when we're going the other way.